You are all welcome to the fourth presentation of our atomic structure and bonding. In this presentation, our focus is going to be on different types of bonds. We have another set of bonds that we sometimes talk about in chemistry, and that is mixed bonds. The formation of mixed bonds is related to the electronegativity series. Rules about bonding is as follows. Two atoms of similar electronegativity form either metallic bond or covalent bond according to whether they can release or accept electrons. Cis covalent bond is additional, whereas ionic bond is not. The degree of the directionality changes with the bond form, with consequent marked influence on the crystal structure. Bond strength and melting point. This is the measure of the energy required to break bonds and vaporize a solid, and hence separate the constituent atoms. Melting points are indicative of bond strength. Melting points occur when the vibration becomes so great that bonds are broken and atoms become more free. Here, to say more about vaporization, we have the following. Among the states of matter that we talked about solids and liquids and gases. It is possible to have a solid which, when heated or which, when provided with energy, the atoms in it will acquire energy such that the atoms that have been vibrating normally about their many positions in the solid, they tend to become violent. When they become violent in their vibration, and it becomes very hard for them to keep together, they actually end up separating. And if they separate and the solid does not become liquid, there are incidences when the solid becomes actually vapor. An example I can give here is with the iodine. We can have a solid form, but when we try to heat iodine, instead of giving us a liquid, we get a vapor. And this becomes a change from one state to another, but a change from solid to vapor state or solid to gas is what we call sublimation. So the substance is said to sublime. For example, we have given the example, and now going to another change of state. We can have our atoms in a certain substance close to one another with a lot of energy between them that holds them together. But if we heat them, say for example, if we provide heat to ice, which is solid water, the vibrations of the molecules in the ice that we want to change to another form, the vibrations of the molecules may become so great that these molecules actually break apart, and then they give us what we call a liquid. In such a situation, we have liquefaction or we have melting. Therefore, melting occurs when a solid becomes a liquid. There is that change of state from solid to liquid. Then we talk about melting point. That is what has just been described here as the melting point of a substance. Valence bond theory. Based on the knowledge of atomic orbitals, electronic configurations of elements, the overlap criteria of atomic orbitals, the hybridization of atomic orbitals, and the principles of variation and superposition, we can now ably discuss what we call valence bond theory, given that knowledge in the background. When two atoms are at a distance which is so large from one another, there is no interaction between them. These two atoms, as these two atoms approach one another, new attractive and repulsive forces begin to build up or begin to occur. Attractive forces arise between 1. Nucleus of one atom and its own electrons, and nucleus of one atom and electrons of another atom. On the other hand, repulsive forces arise between the electrons of atoms of the two atoms and the nuclei of the two atoms. On the other hand, we can also say the following. Depending on the resultant action or the resultant of that action or the result of that action, we can say that the attractive forces tend to bring the atoms close to one another, whereas the repulsive forces tend to push these atoms far apart. Orbital overlap concept. When atoms approach one another, there is a minimum energy state. When the two atoms are so near, there is a partial merging of the atomic orbitals. Overlapping of atomic orbitals and the extent of overlap decides the strength of the covalent bond formed. The formation of covalent bond between two atoms depends on the overlap of the orbitals containing the outermost electrons, and it also depends on the number of the electrons present in the valence shell having opposite spins. The types of overlapping and the nature of bonds. The covalent bond may be classified depending upon the types of overlapping. 1. Covalent bonds may be named as sigma bond or pi bond. A sigma bond is the type of covalent bond that is formed by the end-to-end or head-on overlap of bonding orbitals along the internuclear axis. This head-on overlap or axial overlap is very common when we normally have s orbitals overlapping or s and p orbitals overlapping. The pi bond. In the formation of the pi bond, the atomic orbitals overlap sidewise or side by side with the axes parallel to each other and perpendicular to the internuclear axis. Thank you very much for your attention. We will be back with the 5th presentation.